In this lecture, I am going to derive the formula for the angle of wrap and for the length of the belt, and after that I will try to derive some of the formulas that will be used in the analysis of flat belt. So let's start with the lecture. First of all, these are two pulleys. This is the belt that is wrapped around it. These are the diameters of the two pulleys. These are the points where the contact between the pulley and the belt either starts or ends. So let's join these points with the center, and this is the central distance between the two pulleys. Theta d as the angle of wrap for the pulley of the bigger diameter, represented by theta capital D. As this is 180 degree and we don't know the value of this angle, so let's represent this angle with alpha, and it is also equal to this angle. This is also equal to alpha. Similarly, this angle is also equal to alpha, and this one is also equal to alpha, and this angle is 180. So theta d will be equal to 180 plus 2 alpha, and theta small d will be equal to 180 minus 2 alpha. And if you see over here, this is the radius of this pulley, so it will be equal to diameter small d divided by 2, and similarly this is the radius of this pulley, so it will be equal to capital D divided by 2. Now let's start a line from this point towards this radius such that that line should be parallel to this line. Since this line is parallel to this line, so the distance over here will be equal to the distance over here. So this distance is also equal to small d divided by 2. And since this line is capital D divided by 2, so when you subtract the small d divided by 2 from it, that is going to give you this line. That will be equal to capital D divided by 2 minus small d divided by 2. So it will be equal to capital D minus small d divided by 2. So we know this line and we know this as well because that is equal to C, but we don't know the value of this. But still, this information will be enough for us to find out the value of this alpha. As you know that the angle between these two lines will be equal to 90 degree, and since the angle between this line and this line is alpha, so the angle between this line and this line will be equal to 90 minus alpha. As this line is tangent to this, so the angle over here will be equal to 90 degree, and similarly this line is parallel to this one, so the angle over here will also be equal to 90 degree. And you know that this angle plus this angle plus this angle should be equal to 180. This is 90, this is 90 minus alpha, so this 90 and this 90 will cancel out this 180. So this angle will be equal to this alpha. Now as you know that sin alpha is equal to perpendicular by hypotenuse. The angle over here is 90 degree. This is alpha angle. So this one will be base, this one will be perpendicular, and this one will be hypotenuse. So perpendicular is capital D minus small d divided by 2, and hypotenuse is C. So sin alpha will be equal to capital D minus small d divided by 2C. So alpha will be equal to sin inverse of capital D minus small d divided by 2C. So put this value over here in this alpha, it is going to give you theta capital D will be equal to 180 degree plus 2 into sin inverse of capital D minus small d divided by 2C. And similarly, theta small d will be equal to 180 minus 2 into sin inverse of capital D minus small d divided by 2C. So these are the formulas that are going to be used for the wrap angle. If both the pulleys are equal in diameter, then this diameter is going to be equal to this, so it is going to give you 0, and this divided by anything will be equal to 0. Sin inverse of 0 is going to give you 0. So theta d will be equal to 180, and this theta d will also be equal to 180. Now let's talk about the formula for the length of this belt. So for that, let's divide the length of the belt into components. For example, since over here the contact between the pulley and the belt finishes, so let's start from there and up to this point where the contact between this pulley and the belt is going to start again. So this is, let's say, represented by B. And after that, this is the wrapped length up to this point. Let's represent this one as a small d, and again from here up to this point, that is equal to b, and the distance from here up to here, let's represent that by s capital D. So length will be equal to 2b plus wrap length of the belt, or 2b plus s capital D plus s small d. Now let's find out the value of b and also the value of s capital D and s small d. The value of b can be found from this right angle triangle, because this line is parallel to this line and both are perpendicular to this and this. So let's find out this length, and let it be represented by b. And as you know that this is the central distance, so this is represented by c. So represent this one by a. And as you know that from the Pythagoras theorem, perpendicular square plus base square is equal to hypotenuse square. So first of all, put the value of a. As you know that this a was equal to capital D minus small d divided by 2. So put this value and rearrange this formula for that. B, it is going to give you b is equal to under root c square minus capital D minus small d divided by 2 whole square. So if you take this square on this one and this one, 2 will give you 4, and after that take LCM, that will be multiplied over here with this c square, so you will get 4c square. And after that take this square root on numerator and denominator. So and the denominator, since you have 4, so on the root 4 is going to give you 2. So this is the formula that is used to find out the value of c. And now let's find out the value of this arc and this arc. As you know that s is equal to r theta, so SD will be equal to capital R into theta capital B. Instead of this capital R, you can put capital D divided by 2. And similarly, the small d will be equal to small d divided by 2 into theta. Putting these values, you will get this formula for the length of the belt. This 2 and this 2 can be cancelled out with each other. Now let's find out another formula that will be used in the analysis of the belt and also in the design of the belt. So for that, let's take a small portion of the belt that will be wrapped around the pulley. So this is that part of the belt, and let's join the edge of this belt with the center. If this is the angle theta, is the wrap angle of the belt, and since we have taken a small portion of it, so this will be d theta. Now let's talk about different types of forces that will be exerted on this part of the belt. Let's see, we are exerting a force in this direction so that this belt rotates in this direction. So the tension in this part of the belt will be greater as compared to this part. So in this direction, a force F plus dN will be exerted, and in this direction, force F will be exerted. So you can see that this force is greater than this force by an amount of dN. As you know that this belt is rotating, or it is actually moving in a circular motion. So whenever there is a circular motion, there will be a centrifugal force that will be exerted on that body to move out that body from the circle in which it is rotating. So there will be a centrifugal force ds on this belt. There will be a normal force as well on this belt. For example, let's say you have a table, and on this table there is a book that is lying on it. So this table will exert a force on this book, and this force will be normal to this surface. So this is called normal force. So over here, since the pulley is like this, so normal to this surface, there will be a force on this belt, which will be like this, and that is represented by dN. And since the belt is moving over the surface of the pulley, so there will be a friction force as well, opposite to the motion. So that will be equal to F dN, where F is the coefficient of friction. Now let's talk about this centrifugal force, as it is represented by ds, and centrifugal force is equal to mass into r omega square. But here for this field, mass is actually given in a unit of kg per meter, or mass per unit length, as this length is actually r. So this L can be replaced by S. This is represented by M. Mass will be equal to ms. As you know that this S is arc length, so arc length is equal to R into angle, and angle over here is d theta. So mass is equal to mr d theta. So instead of this mass, you can put mr d theta. Now when you multiply this over here, it is going to give you r square. So r square omega square will be equal to r omega whole square. So instead of this r, and omega square, you can put r omega whole square. And as you know that r omega is equal to v, so instead of r omega, you can put v. And as you know that centripetal force is equal to mass divided by r multiplied by v square. So instead of this, you can put m. So centripetal force Fc is equal to mv square. So instead of this mv square, you can put Fc over here. So ds will be equal to Fc d theta. Now let's resolve this force into radial and tangential component. As this line is radial line, and similarly this line is tangential line. So when you divide this into its component, so this component will be tangential component and this component will be radial component. And the angle over here will be 90 degrees. If you can see, this line and this line are perpendicular to each other, and similarly this line and this line are perpendicular to each other. So if you move this line by an angle of d theta by 2, this line will come over here to this radial line. And similarly, if you move this line by an angle of d theta by 2, it will come over here, because both this line and this line are rotated by an angle of d theta by 2. So they will still be perpendicular to each other. As this line came over here, so this line would come along this line to be perpendicular to the line that is shifted from here to here. So in other words, we can say that this angle is also equal to d theta by 2. So we got a right angle triangle, that is this. The angle over here is 90 degree and the angle over here is d theta by 2, and this line is f plus df. So this component will be f plus df sin d theta by 2, and this component will be f plus df cos d theta by 2. And theta is very small angle, so d theta by 2 will be small further. So sin d theta by 2 will be equal to d theta by 2. So instead of sin d theta by 2, we will put d theta by 2. And similarly, you can do the same for this force as well. So this component will be f d theta by 2, because sin d theta by 2 will be equal to d theta by 2. And similarly, this component will be. Now, first of all, let's add all the forces in the radial direction. But for that, let's specify the positive directions as well. Let's say this is positive direction, and similarly this one is also a positive direction. So this force will be positive. Similarly, this force will be positive. This force will be negative, and this force will also be negative. So this force is taken with the negative sign, and similarly this force is also taken with the negative sign, and this force and this force are taken with a positive sign. Now multiply this f with this and also this with this. So it is going to give you this equation. Now we can add this and this with each other, and d theta is very small and similarly df is very small. So when they are multiplied, they will give further small values. So we can ignore this. So it is going to give you minus f d theta. So dn will be equal to f d theta minus ds. Now let's add the forces in the tangential direction. This one is in the tangential direction. Similarly, this force is in the tangential direction. Similarly, this force is in the tangential direction. This is in positive direction. This is in negative direction. Similarly, this is also in negative direction. But if you see over here, d theta is very small value. So d theta by 2 will give you further small values such that it can be considered to be equal to 0. And cos 0 will give you 1. So instead of this cos d theta by 2, you can put 1. So it is going to give you f plus df, and similarly this component will give you f. So this force in the positive direction and this force in the negative direction, and similarly this force in the negative direction. This f and this f will cancel out each other and bring this onto the other side of the equality. It is going to give you df is equal to f dn. Now put the value of dn from this equation over here. That is going to give you this. Now instead of ds, put this value, and after that multiply this f over here and over here. It is going to give you this. Take d theta common from them, which will give you this equation, and after that divide this on both sides. You will get this equation. This is actually a first order non-homogeneous differential equation. So is actually represented by this equation. And to solve it, first of all, what you will have to do is to find out the integration factor, which can be calculated by this formula, that is I of x is equal to e to the power integration of p of x. So y will be equal to this. This is the integration factor. This is integration factor into p of x here. And you will have to add constant as well over here. So over here, theta is actually x and p of theta is minus f, and q of x is actually equal to minus f m r square omega square. Now let's find out the integrating factor for it. So instead of p of x, we will have to put p of theta, and p of theta is actually minus f, so put minus f, and that is going to give you e to the power minus f theta. So put this over here and over here, and similarly this q of theta over here is going to give you this equation. So this will be the solution for f. The denominator, this minus will become plus. So we have written plus over here. And similarly, you can bring this out from this integration because it is constant, so we have bring it out. And similarly, we have written exponential of minus f theta d theta plus a. When you integrate this, it is going to give you this. This minus f and minus f can get cancelled out with each other. And similarly, this will be multiplied over here and over here. So this and this can be written like this as well, which is this power. So this will give you 0 and e to the power 0 will give you 1. So instead of this and this, you can put 1. So you will get mr square omega square, and this e is multiplied over here as well. So f will be equal to this. Now if you assume that the angle theta starts at the loose side, so at the loose side theta will be equal to 0 and f will be equal to f2. To put this condition over here, that is going to give you this equation, because if you see over here this theta is 0, so 0 multiplied by anything is equal to 0, and then e to the power 0 will give you 1. So instead of this, you will put 1. So f2 will be equal to mr square omega square plus a. Bring this mr square omega square to the other side of the equality, you will get this equation. So instead of this a, we can put f2 minus mr square omega square. After that, when you go to the other side, the tight side, the angle over there will be equal to rap angle represented by pi, and the force F over there is F1. So put F1 and instead of theta, put pi. So you will get this equation. Now after that, bring this over here. You will get F minus mr square omega square, and after that divide this whole term. You will get exponential of F pi is equal to this. And as you know that mr square omega square is equal to fc, so you can put fc instead of them. So you will get this equation, and multiply this over here, you will get this equation. After that, multiply this with this and this, you will get this. And after that, subtract f1 exponential of f pi on both sides. Take f1 common from these two, and similarly exponential of f pi from these two, and bring fc over here, it is going to become plus f. And after that, take fc common from both of them, so you will get this. After that, bring this over here, so this positive sign will become negative on the other side of the equation like this. Now since this is common in these two, so take this common out from these two, you will get this equation. And after that, take minus common from these two. So this negative sign and this negative sign will be cancelled out with each other to become positive. So you are going to get this equation. And after that, divide this over here, you will get this equation. As you know that x is equal to this, so instead of this r square omega square, you can put v square. You know that weight w is equal to mg, so m will be equal to w by g. So instead of this m, we have put w by g, which is weight divided by gravitational acceleration, and r square omega square will be equal to v square. And since you will get this v in units of, and this v is actually in feet per minute, and to convert that minute into second, you have to put
60. And similarly, this G, which is 9.8 meter per second, to convert this G to feet per second square, you will have to put 32.17 feet per second square. And as this V is already in feet per second, you will not need to put 60 over there. So this is FC, and similarly D can be found from this equation, that is pi dm divided by 12. This n is actually the RPM of the pulley, and similarly this diameter will be in the inches. So to convert inches into feet, we will have to divide it by 12. And this n will be in the revolution per minute. So this will be revolution per minute. Since you have put pi over here, so RPM will be converted to radian unit. So for n, you will get radian per minute. And since this was in inches, you put 12 to convert it into feet. So velocity will be in feet per minute. That is why we have put 60 over here to convert this minute into second. Now after that, let's consider this belt that is wrapped around this pulley. Now what kind of forces will be exerted on this belt? When you are manufacturing this belt, you will have to give some initial tension to this belt. And similarly, since this is rotating in this direction or in this direction, so there will be centrifugal force as well, and those forces will give further tension to the belt. So we have added FC over here, similarly Fi over here and over here as well. And since this one is the tight side, because let's say you are pulling it from this side, so delta F by 2 will be added over here, and similarly, since this is the loose side, so you will have to subtract delta F by 2 over here, and this delta F by 2 will be equal to C by D. So these will be the forces that will be exerted on this belt. If you subtract F2 from F1, so this will become minus, and this one will become minus, this will become minus, and this will become plus, this will become plus. So this and this will get cancelled out, and this will get cancelled out, and these two will be added with each other. So that is going to give you 2 T by D. And similarly, if you add F1 with F2, this and this will give you 2Fi, and this will give you 2FC, and these two will be cancelled out with each other because this is negative and this is positive. So these two will be cancelled out with each other, then common 2 from both, so you will get this. Now after that, divide this 2 over here and bring this FC to other side of the equality. It will be with negative sign. So this Fi will be equal to this, and divide this 2 over here. If you divide this Fi T by D, then you will have to divide this with this. You will get this equation. Now take LCM, so 2 will be multiplied over here as well, and this 2 and this 2 will get cancelled out. You will get this equation. After that, since this is 2 FC, so you can put 1 FC with this and 1 FC with this. Add and subtract FC over here. Add this FC over with this, like this, and this FC with this. But when you take minus sign common from them, so this positive sign will become negative. So you are going to get this equation. After that, divide F2 minus FC and the numerator and denominator. So when you divide the F2 minus FC and the numerator, so FC will be divided over here as well, and with this as well. So this will give you 1, and this will give you this. And similarly, when you divide F2 minus FC and the denominator, that will be cancelled with this. So you will get 1 over here, and this written over here. Now, as previously we obtained that this is equal to exponential of F pi, so instead of this we can put F pi. So Fi divided by T by D is equal to exponential of F pi plus 1 divided by exponential of F pi minus 1. Now multiply this T by D over here and this over here, and similarly divide this over here. You will get this equation. As I told you, F1 is equal to this. So instead of T by D, you can put this value,
So when you put this value, you are going to get this. Now take Fi common from both. So you will get 1 over here and this over here. So 1 plus this and 2f plus fc will be equal to f1. Now take LCM. So multiply this term over here with this one. You're going to get this. Now this and this will get cancelled out with each other, and these two will be added with each other to give you 2 into exponential of f pi. So you are going to get this equation. This is f1. And similarly, the same procedure can be applied for f2. So instead of this p by d, you can put this. So after putting this, now you can take common fi from these two. So you will get this. After that, take LCM for it. You will get this. Now this and this will get cancelled out with each other. And 1 plus 1 will give you 2. So you will get this equation. So f2 is equal to this. So these are the formulas that will be used to analyze the build, or these formulas will be used in the design as well. And the power that will be transferred can be calculated by this equation.
Here, I just want to make one point, that is, let's say you have this pulley and there is belt wrapped around it. Now, if you exert forces on both the ends be equal to each other, you will not be able to rotate this pulley. Power will not be transferred. It will be static, because if you transfer this force along this belt at this point, when they meet, since both are equal in magnitude but opposite in direction, so they will get cancelled out each other, so no power will be transferred. But if this is F1 and this force is F2, and there is slight difference between these two forces. So if you transfer this F1 over here like this, and similarly F2 over here like this, so F1 minus F2 will not be equal to 0, so this pulley is going to rotate, and hence power will be transferred. That is why we have written F1 minus F2 over here, which is delta F. But here I'm going to tell you that instead of this F1, you will have to put F1. It is because we have F in unit of Newton per meter. So this meter will be cancelled out with this width. And we have put pulley correction factor as well, because you can see that when belt rotates over the pulley, there is a slip phenomena as well. Belt will slip over the pulley, so you will have to put pulley correction factor as well. And similarly, since this belt will be for particular speed, so you have to put velocity correction factor as well if you get another velocity for which it is not designed. So these formulas will be used in the analysis and in the design.